In the growing conversation about clean energy, hydrogen has taken center stage as one of the most promising, yet misunderstood technologies. On the surface, it appears to be the perfect fuel. It can power vehicles, emit nothing but water vapor, and offers a quiet, efficient alternative to fossil fuels. In places like China, it's already being used in heavy-duty trucks traveling over 1,000 kilometers without refueling. But beneath that clean image lies a complicated truth. Hydrogen is only clean if it's made cleanly, and that's where the confusion begins. Watch a hydrogen-powered truck as it hums quietly down a highway, and it's easy to believe you're witnessing the future. There's no black smoke, no roaring engine, just a sleek, whispering machine, and a plume of harmless water vapor trailing behind. This image has helped fuel hydrogen's reputation as a climate solution, but it masks a deeper issue. Hydrogen doesn't occur naturally in its pure form. It has to be produced, and how we make it determines whether hydrogen helps fight climate change or silently contributes to it. To understand hydrogen's environmental impact, we need to talk about its colors, not literal colors, but color-coded labels that describe how it's made. Gray hydrogen, the most common type, is produced by extracting hydrogen from natural gas in a process called steam methane reforming. This method releases large amounts of carbon dioxide, so much in fact that it can be worse for the climate than burning the fossil fuels it aims to replace. Then there is blue hydrogen, which uses the same basic process, but tries to clean it up by capturing and storing the carbon dioxide before it reaches the atmosphere. While it's better than gray hydrogen, it's still reliant on fossil fuels and carries the risk of methane leakage, a gas that's over 80 times more powerful than carbon dioxide in the short term. Now, green hydrogen is the ideal. It's made by using renewable electricity to split water molecules into hydrogen and oxygen through a process called electrolysis. When powered by wind, solar, or hydro, this method produces no greenhouse gases at all. It's the clean hydrogen everyone talks about when they envision a green future, but it's also the least common and the most expensive today. So, while hydrogen fuel cell vehicles emit no pollution at the tailpipe, the true environmental impact depends on what happens before the hydrogen reaches the vehicle. That's the nuance often missed in public discussions, and one of the main reasons hydrogen is often misunderstood. Despite these challenges, nations around the world are investing heavily in hydrogen, none more visibly than China. In 2024, the China Aerospace Science and Technology Corporation, or KSC, successfully tested a liquid hydrogen fuel cell system capable of powering heavy-duty trucks for more than 1,000 kilometers, or 621 miles, on a single refueling. That's roughly the driving distance between Beijing and Shanghai, a range previously thought difficult to achieve with clean technologies in large vehicles. Not long after, Chinese vehicle manufacturer Yutong carried out a massive real-world demonstration. A fleet of hydrogen-powered trucks embarked on a 1,500-kilometer or 932-mile journey across 6 provinces. Beginning in Beijing, the trucks passed through Tianjin, Hebei, Shandong, Jiangsu, and finally reached Shanghai. Each truck used a 180-kilowatt fuel cell system, delivering impressive performance even over long distances and under real traffic and road conditions. These tests weren't just a show of engineering. They were a clear message that hydrogen fuel cell systems are no longer a distant concept. They're ready for real work. China's testing ground is not just proving technology, but also laying the foundation for a nationwide hydrogen economy, complete with fuel infrastructure and manufacturing ecosystems. With electric vehicles gaining dominance, especially in passenger transport, one might wonder why hydrogen still matters. The answer lies in use cases where batteries struggle to compete. Hydrogen fuel cells are lighter than large battery packs and refuel much faster, typically within 5 to 10 minutes, compared to hours for large EVs. That makes them ideal for applications like heavy-duty trucks, where long range and minimal downtime are essential. Public transportation, where buses have to stay on schedule and avoid lengthy charging breaks. And industrial machinery, where high power output is required over long shifts. Hydrogen is also more adaptable in extreme climates, where batteries often lose efficiency. For logistics fleets, hydrogen offers the reliability and flexibility that electric battery options can't always deliver. Still, hydrogen is not a perfect solution, and there are places where it may never be practical. In aviation, hydrogen has been proposed as a future fuel, and while there are experimental hydrogen aircraft in development, major challenges remain. One challenge is that liquid hydrogen must be stored at -253 degrees Celsius or -423 degrees Fahrenheit, requiring bulky, heavily insulated tanks. For passenger planes where weight and space are tightly restricted, this creates major design and efficiency problems. A few niche applications like regional flights or unmanned aerial vehicles might work, but for large commercial aircraft, hydrogen will likely remain on the fringes unless storage technology takes a massive leap forward. Maritime shipping is responsible for nearly 3% of global carbon emissions, and hydrogen has been floated as a possible alternative to heavy fuel oil. But here too, storage becomes an issue. Hydrogen's low energy density means enormous tanks would be needed to carry enough fuel for long ocean voyages. Some short-range or hybrid vessels might use hydrogen, but the bulk of global shipping may turn to other clean alternatives like ammonia or biofuels, which are currently easier to store and transport. The military has expressed interest in hydrogen fuel cells, especially for stealth vehicles and quiet power generation in remote locations. Hydrogen's silent operation and low heat signature are useful for surveillance and special operations. However, the logistics of storing, transporting, and refueling hydrogen in battlefield conditions make it far less attractive for large-scale deployment. Diesel currently remains far more practical in most scenarios. So while hydrogen can serve critical roles in certain military tech, it won't be replacing jet fuel or tactical vehicle diesel anytime soon. The biggest obstacle to a truly clean hydrogen economy isn't the technology. It's the source. As of now, more than 95% of the world's hydrogen is still gray or blue. That means we're still deeply tied to fossil fuels, even as we build vehicles that emit nothing. But there's momentum growing, as China, Europe, and the US are investing billions in green hydrogen infrastructure, research, and development. Electrolyzer costs are falling. Renewable power is becoming cheaper and more abundant. As the demand for clean hydrogen fuel grows, the more incentive there is to build a truly green supply chain. Hydrogen won't power everything. It won't make electric vehicles obsolete or revolutionize aviation overnight. But for specific sectors, long-haul transport, logistics, and heavy machinery, it remains one of the most promising ways to decarbonize without compromising performance. Hydrogen is not inherently clean. That's the critical misunderstanding. But if it's made the right way, with renewable energy and smart policy, it can be a powerful tool in the fight against climate change. China's recent fuel cell truck tests show just how close we are to a working hydrogen economy. The challenge now isn't the truck or the technology, it's how we power it. If we can turn the tide from gray and blue to green, hydrogen may just live up to its promise as the clean fuel of the future, not just clean at the tailpipe, but from source to wheel. The future of green hydrogen fuel is promising. Before you go, check out some of my other videos. Don't forget to hit that like button and subscribe. Thanks for watching. We'll see you at the next one.